Alright, so we've seen how to do periodic noise. So now let's talk about how to distort noise maps. So we've seen a little bit of distortion, or actually like modifying bitmaps or textures in the previous lesson. So this one will primarily deal with how to distort a noise map using another noise map, or like other techniques. So this is actually a pretty huge area. So I'm going to sort of narrow it down for this one, and I'll try to do like 2 examples. So it'll give you at least some kind of a practical example of what you can use it for, because otherwise it just sort of spirals out of control. Like you can do n number of things with it. So what I'm going to do is I'm going to make something that looks like concrete, and then I'll do another one which looks a bit like marble. Okay, so we'll do like 2 examples like that. And what I have is I just have like this grid. Okay, so I have a grid and I gave it a UV map, but the UV map is for a specific purpose. Otherwise we're not really using it. Okay, so let's get started. I'll create a new file and I'll create a geometry and a grid, and I'll just give it a UV map. So we'll give it a UV project and we'll keep it to points. I'll just press enter. I'll do initialize, or actually most of this is fine. I'll just keep it to 1 and 1. Yeah, okay, there we go. So this is good. Okay, so what I want to do is we'll just take an attribute warp, and first we'll just talk about this in a very simple way. So the way it works is we're modifying the UV data that is coming in. So in case of a noise map, you're feeding in the position, and what we do is we modify, or if we distort the position, it distorts the noise map. Like it's pretty much as simple as that. If I take a standard turbulent noise and I'll just plug in the position and I'll plug in the noise, we'll set it to original Perlin. And what I want to do is, let me just take a fit range, or a fit range unclamped. I'll make it minus 0.5 by 0.5. Okay. And let's make it about 2. And I'll give it an offset of about 40. Okay. Or I don't want dark spots. So yeah, okay. I think this is fine. Okay. So this is the basic map that we have. So what you can do is, the only thing you need to remember is that since position is a vector, if you're going to feed, or if you're going to modify it with another noise map, that noise map should also be 3D. Like it can't be a 1D noise map, because the default you work with a 1D. Okay, so if you turn it to 3D, you'll see that it becomes colored. So that is what you need to do. Okay, so all you have to do is take another turbulent noise. We'll give it position and set this to 3D, and we'll make it sparse convolutions. And I'll just do a multiply constant, and then we'll just add it with the existing noise map, and there you go. So it looks like right off the bat it looks nice, like, because the problem is just having a basic noise map, sometimes you don't get the result that you want. So distorting noise maps is always a good idea. Even for like general texturing, it's very rarely that working with just the basic noise map helps. You usually want to distort it a little bit. Okay, so I'll just plug that in, and I'll offset this as well. So the difference is, let me also just do a fit range here. So the difference is, if I make it 1D, this is what happens, and then this is 3D. Now it won't make a difference right now, but in another example, you'll get an idea of how much of a difference it makes. So you can increase the roughness. Sparse convolution is actually pretty cool. Like you can do some nice fancy things with it. And let's just try to animate this. So I'll take a float to vector. I'll plug in the time into the y-axis, and again let's put a multiply constant in the middle, and I'll plug this into offset, and there you go. So if I just lower this. Okay, let's lower it further. There you go. Oh, that looks nice. And it looks like it's boiling or something. Okay, and you can also we can increase the intensity. So let's say if we make it 4, and let's try to up this thing a little bit. Let's try to modify that. Okay, there you go. Yeah, so it looks pretty good. You know, like even if you're just doing like, even if you want to do like random patterns or something, it looks nice. So if I try and plug this into, let's say like a displace, it could look interesting. Like I could just take this amount and plug it in there. Okay. And then just, you know, like lower it. Maybe lower the roughness on the final one. And then I can just, let's also put in a color just for fun. And I'll set it to ramp from attribute, CD, set it to two-tone. Yeah, okay. That looks interesting. Okay, that looks fine. So yeah, you can do fancy enough things with this. Like even just doing this much looks interesting. And then we can try to increase the resolution here. Okay, now it won't play back as smoothly, but there you go. Like even if I remove the diffuse, even if I remove the displacement, it might still look interesting. There you go. The thing to remember is that everything that I'm doing here at SOP level, you can also do this exact same thing in Mantra, like the nodes remain exactly the same. And you can also do it with COPS. Okay, so if you want to write this out as a texture, you can take the same data and take it into COPS and then, you know, just do a file output and you'll get, you know, exported as a texture, and you can use this as a texture in any other software. Or even since a majority render engines support you know, taking an input from COPS, you can use this as a texture in, you know, any render engine that you want to. So what I'll do is at the end of this lesson, I'll just try and take all of this and transport it to COPS and, you know, see what result we get. Okay, so this is basic. Okay, now, as I said, like it's a huge topic, so you can do a lot of things with it. So I'll do something, as I said, I'll do like 2 examples. Okay, so first let's take a look at this, which is, you know, it's more like a lunar surface, but yeah, you can probably use this as concrete as well. Okay, so we'll do concrete. So I'll take a simple attribute warp, and the first thing I'll do is I want to set up like a grid. So we'll take boxes. So I'll take boxes, and you can get UV coordinates. So we can just plug in the UV coordinates and the amount goes into color. Yeah, just the reason why it's not working is because the UV coordinates are kept to vertices. So change it to points, and there you go. So if it's not working, just make sure that, you know, you've kept it to the right context. And I'll reduce the blur. All right, so what I'll do is I'll just make this 2 by 2. So this is good. This will be my tile. The other thing we want from this is we want like a grayscale, like random pattern coming out of these boxes. So what I can do is I can take the seed. The seed will give you this, but if you feed it through a random node, so we'll take a random BRJ and I drop it in the middle, and see, this is what you'll get. And the random BRJ is nice because it gives you, you know, like an offset value inbuilt, so you can get, you know, different results. So we'll need this, but for now, you know, this is fine. Okay, so just, you know, we'll disconnect this and I'll take it a little further back. And the first thing I'll do is I'll just set up a turbulent noise, and we'll just, you know, do it from scratch. So add this, take another turbulent noise. This one we'll work with sparse convolutions, keep it to 3D. This comes in here, and again do a multiply constant. Yeah, and here I'll take a fit range unclamped and make it minus 0.5 to 0.5. I'll keep this to Perlin, and frequency will keep it to 2, and the offset here I'll keep it to 40. Okay, so if I plug in the sum and take this out to color, we should get this, which is the same as we were getting before. Let's offset this. Okay. And let's increase the roughness here. and we'll also increase the roughness of this. See, there you go. So that looks a little better. And what I can also do is just take this and make it, slightly light gray like that. If you don't want to change it here, you can change it through like a color node. Like what I can do is I can probably just take a ramp and then, color it that way. But I'll just adjust it here itself. And I'll take the multiplier and make it about 3. So you get like, a fair bit of distortion. And we can try to lower the, we don't need to lower the attenuation. Alright, another change I want to make is with this turbulent noise, I'll make the frequency about 4. So you get like a fair, there you go. Now you're getting like a fair bit of detail. But let's just lower the amplitude. I don't want it this much. Yeah, I think around, I think around 0.5 is good. See, so this gives you like a fair bit of, detail on the whole thing. You can try to up the roughness. No, not here. Let's try to up the roughness here. Okay, I think this is fine. Okay, so now comes the more interesting stuff. Okay, what you can also do is you can try to up the turbulence, because what the turbulence does is it gives you like more of the finer grain that you weren't getting. So this is a little smooth. So if you get the turbulence up to about 8, it looks nice. Okay, so now what I want to do is at a very simple level, if I just do a multiply, and I multiply this with the box. See, so that's what you get. But what I want to do is for each sort of square, I want to offset them. Okay, so this is again where, because mantra is, or because, VOPS is so open, you can not only modify the position, you can modify literally any of these parameters. Okay, which is where it becomes, really interesting. So what I can do is, let's say I want to offset this in maybe like the x-axis. So what I can do is I can take this random BRJ. I want to offset both of them, this turbulent noise and that one. So I'm just going to pull this back. I'm going to take a fit range, and then I'm going to take a float to vector, and we're going to modify the x. Okay, so this goes a little bit back here, and I want 2 of these. So Control C, Control V. Okay, so this one, and what we want to do is we want to take the basic value and go from, let's say, -30 to +30. And if I take this and I plug it into the offset, see, there you go. Okay, like if I remove the multiplication, you should be able to see a result. See, so now you're getting, like a breakup over there. And the same thing here, I'm going to make it -50 to +50. But I'll take the random BRJ and just modify the seed. And this comes into this offset. And yeah, there you go. See, that isn't bad. Like I plugged it into amplitude, which is pretty cool. Okay. Yeah, well, that was a happy enough accident. Hold on. But let's just plug that into offset. There you go. And we can try changing the the seed values, and you'll get different results. So this is pretty cool, right? So you can do stuff like this, and then we finally take that multiply again, which is, like take this guy and plug it back in over there, and that gives me, a decent enough result. Let me just try that one for a second. We'll do Control C, Control V. I'm going to plug that into amplitude. See, okay. And what I'll do is I'll take a fit range here at the end, so that will just clamp the result, which isn't bad. Let me just, let me take this to around 30 and -30. Okay, that looks, it's almost the same. Actually, we can just take this and, that's not bad. See, you're getting like these nice little bands on the whole thing. Anyways, that's not the result that we want, but you can do some interesting stuff with this. Okay, but anyways, this is the basic result that we wanted. Let me get rid of that. Yeah, there you go. And then if you want, you can plug this into a displace, which is not a good idea in this case. I can just take this multiply and drop it in there. Yeah, and just like lower it a lot. Yeah, there you go. See. Yeah, so this gives you, you know, like a basic, I don't know, hopefully like a concrete like structure. Okay, let's call this concrete. Okay, the next one I want to do is like a marble. So we'll get like another warp. So we'll take another attribute warp and I'm going to plug this in. Let's call this marble. And I have an image. There you go. So if we look at it, it's mostly like you have like a cellular, like a large cellular structure, you know, like it's like a whirly cells and those lines are getting distorted. Okay, so that's roughly what we want. Okay, so what I can do is I can come in here and I'll pick up a unified noise static and I'll just put like a add in the middle because we're going to need it anyways later. And I'll also take a multiply constant just for now and plug that into position and then take this noise and plug it in there. And then what I can do is just change this to whirly F2 F1. So we'll get this, okay, which is nice. So now what I can do is firstly I'll just give it some standard FBM. So it's a little bit noisy like that. So now what we want to do is we want to distort this. So we'll take a turbulent noise and I'll offset a little bit and set this to 3D and we'll set that in there. So we'll get this. So what I want is like I want two noise maps to modify. Okay, I want one which will cause the larger distortions and then another one which will cause the smaller distortions. Okay, so this one is the larger, you know, this one will cause larger distortions and can try to increase the roughness, but no, hold on, take it to original Perlin. Yeah, that's not bad actually, that looks decent. And we can increase that, no, not too much. This one will keep it low, like not a lot. I think this is okay. Okay, and then I'm going to duplicate this. So Control C, Control V and plug that in. Except this will be, let's try 4. Lower the multiplier a lot. There you go. So you're getting like the smaller distortions and increase the roughness. So we'll get this. And let's try to offset it a bit. Yeah, okay. This looks nice. You can then adjust, you know, like how much you want to distort the whole thing. Let's try to offset this as well. Yeah, I think that's fine. That looks nice. What I can also try is I can try to stretch this a little. So let's take the Z axis and make it 2. So it kind of, you know, stretches out a little bit, which is fine. Okay, so now what I can do is I can just take a ramp parameter and we'll just color this. So I'll just, you know, get a little bit of external control over it. So I'm going to take this and plug it in and let's make this, I don't know, like a blue or something. Yeah, okay. And then I can just take this and plug it like, you know, yeah, there you go. See, so that looks nice. Yeah, that looks interesting enough. Now what I can also do is like there is like the larger cracks and then the smaller ones. So what I can do is I can just duplicate this, you know, I can do like a Control C, Control V and make it let's say 2, 2 and 4. Like the first one is 1, 1 and 2. And then I can take a fit range here and we'll multiply it with this. So I'll put a multiply in the middle and just, you know, plug that in. Yeah, but what I'll do is I'm going to just, you know, like adjust the, you know, the cracks. So they're just like a little bit and then increase the destination minimum. So you just have like a few of them. See, so it's not like a lot. Okay, it's just a few of these and then you can sort of control the, you know, the incoming value. So you get like a little bit of additional cracks on top. See, there you go. And then just play around with the, you know, the turbulent noise to see how much you want to distort the whole thing. Yeah, that's not bad. Okay, and then you can try to like, you know, offset this a little bit more and see what other results you can get. Yeah, I think this is fine. And then the same thing we did with the concrete, you can do it here, right? So if you can take a box and then, you know, if you want like 4 different, you know, marble tiles, then you can just sort of, you know, offset them and modify them any which way you want. Okay, so, you know, that's always a possibility. All right, so before I close this lesson, what I'll do is I'll take this, and as I had said, I'll transfer it to COPs. So what I'm going to do is I'm going to create a COP network. And let's do one thing. Let's come into the marble and I'm going to copy this much. So we'll do Control C. If you've never done COPs before, this is not an introduction to COPs. Okay, because honestly, I haven't touched COPs in years. So this is the first time I'm actually coming back to it in a very long time. So what we're going to do is we'll just type in WOP and we'll get a WOP COP generator. Okay, you can get a WOP COP filter, but we don't want a filter, we want a generator. Okay, so just take a generator, let's call it marble. And the way it works is that it's a little more work in just like a slight way, which is it can't output just a color. You have to split out the color into RGB. And you don't get a direct position, you get X and Y, because that's like the, you know, length and width of the image. The default image is kept at 1920 1080. So if you come into image tab over here, you get something called override size, and we'll make it 640 by 640. So you'll get this. Okay, and then just to show you how it works, if we take a turbulent noise, the first thing you need to do is take a float to vector, and we'll plug in the X and Y over here. That goes into the position. And then let's say I want to color this. So I'll take a ramp parameter. I'll call it color. And then this can't directly connect into this. So what you need is you need a vector to float. And then this, you know, will connect in there. See, so you'll get that. And this comes in here. So there you go. Okay, so now I can come up here and you'll find your ramp and you can adjust it. So whatever you want. So you can, you know, make those adjustments over here. So this is it. Like, this is just the basics of, you know, how to make a basic COP generator or a WOP generator in COPs. Now what I'll do is I'll get rid of some of this, or actually let me just press Control V and let me minimize these guys. Okay, so all of this is fine. What I need to do is I need to take this float to vec, which is basically my position. Okay, and this will come into like 3 places. So these 2, and then the third one will be here. Okay, so this comes into this position and that one, and lastly over here. Yeah, and what I can do is I'll just move this up. Okay, so this is good. This is done. Now all you have to do is just take this multiply, and if you've done everything right, it'll just work. Which is, I can just take this multiply and connect it to this ramp, and there you go. You have your marble texture. Okay, and now the nice thing is, I can save this as an image if I want. Okay, so I can just directly save this as an image to a JPEG or whatever. And if I want it larger, I can make it, let's say 2048 by 2048, and it'll automatically stretch up, okay, without any issues. Okay, and if you feel like it's, you know, if it's blurry or whatever, we can just come in here and we can up the roughness or whatever. Like, I can just take this and see, I can, like, you know, up that roughness. It takes a little bit of time to calculate, but there you go. You know, so now you're basically, you know, like resolution free, and this is an actual image, so you're not at like polygon level or anything. So you can just make it. And the nice thing is, whether it's Octane or Redshift, or I don't know about the other ones, but I think Octane and Redshift do. But they support, like, you know, you can take like, we can put a null here and do an out, and then you can bring it into a texture, okay, and use this as a texture in your render engine. So you can do that as well. So yeah, like, everything that you're using, you can just bring it into corps and actually bake out textures that you want. So life becomes, or things become far more interesting, okay, rather than just keeping it at SOP level. Next lesson we'll do an example of periodic noise. Okay, like do a proper, like, usable periodic noise example, and then after that we'll come back to modifying noise maps and doing more stuff. And then once you're done with that, then I'll move on to doing like the VDB stuff, okay, which is the more fancier things.